Yes. So good morning again. So I'll be continuing with the yesterday's topic itself. That would be analysis of overtaking side distance and some numerical examples on overtaking side distance. So this has already been discussed. The three components of OSD. So can you hear my voice, or can you hear me any echo in my voice? Is my voice clear? Just want to confirm.
Yes, sir. Clear.
Okay, sir. Thank you. Muting all if possible. Any doubts or feel like there is a network issues, you can raise your hands. Yes. So moving back to, these are the three components in overtaking side distance. That is first D1. So D1 is a distance from position A1 to A2 of vehicle A. Next D2 is the distance from position A2 of vehicle A to position A3 of vehicle A. In between, we should also consider the position of vehicle B, that is B1 and B2 positions. So that's why B2 is split into three, that is spacing between vehicle A and vehicle B before overtaking, and the distance between the position B1 and B2 of vehicle B, we represent it as small b, and again spacing small s, again the distance between vehicle B and vehicle A after overtaking. The positions you can see here, B2 and A3 after overtaking. That was about second component D2. Third component is D3. So D3 we consider, so for example, whatever the diagram shown here, it is a two-lane highway with a two-way traffic without any divider in between. There is no divider in between, or traffic separator in between, or median in between. So that's why this is two-lane, two-way traffic highway. So that's why we need to consider the opposite vehicles coming also during the overtaking operations. So here the opposite vehicle is C. So the distance between C2 and C3, the distance between C2 and C3 is D3. So distance between C2 and C3 of vehicle C coming in opposite direction is D3. So that is the third component. So even while solving the numerical examples, try to determine D1, D2 and D3 separately and add all those, that which gives us the overtaking side distance, that is D1 plus D2 plus D3 in case of two-lane highway with a two-way traffic. Two-way means two-way in this way, both the direction there is a direction of flow. If there is only one-way traffic, then you no need to consider D3. You can leave D3. Okay, so coming to each component formula, we can go through here. Again, I've discussed already how we got this formula. So D1, the first component is VB into small t. So VB, so here V is in meter per second. Why VB? Since the vehicle A is forced to reduce its speed to VB. Actually, its speed will be V. This design speed of vehicle A will be V, small v in meter per second, but it will be forced to reduce its speed to VB because it will wait behind the vehicle B to find an opportunity to overtake. So that's a VB into T. So we can find out D1. Next, coming to D2. As already said, what is D2? D2 is the splitting into three terms, right? So splitting into three terms, right? Here I've written clearly. Here you can see below. Sorry. So here D2. What is D2? Spacing S plus B plus S. So from the diagram already explained, right? Moving back to here. So what again in those three parts, each part is having its own formula. So the formula you can see, yes, this is an empirical formula given. So you can make use of this empirical formula to determine S, spacing S, if it is not given. And again, another formula that is for B, small b is equal to VB, that is the speed of the vehicle A while overtaking, into capital T, that is the time during overtaking operation. So that is B. So now you know S and now you know B. So what is D2? Already which I have shown here. What is D2? Small s plus B plus small s from the diagram. Later on, so yes, this is the empirical formula. Please try to remember it. 0.7 into small VB plus 6. Actually, this 6 is nothing but it is based upon the length of the vehicle from one front wheel to back wheel. The whatever the distance is there, that's based upon that they have given that 6 plus 6, and again B. Okay, so this all put together, you can get this formula. So already I have shown here. That is D2 is equal to S plus B plus S, which can again be written as 2S plus B. So if you put in place of S the empirical formula, and in place of B if you put VB into capital T. So this will be the formula, final formula of D2. Or else there is another formula, they are given capital T. Another capital T formula is also given, an empirical formula is also given, the square root of 4S by A. So you can put in place of T square root of 4S by A. So D2 is equal to 2S plus VB into square root of 4S by A, or D2 is equal to 2 times of in place of S formula, and you can do. So you can use any of this formula. No need to worry. So just remember the whatever the main formula of D2. What is the main formula of B2? D2 is equal to small s spacing S plus B. Yes, so this is S not T, this is plus S plus B plus S. So this is the formula, and you should know this empirical formula of S and another formula for B. Hope I'm clear. So the final formula, that's what this is the final formula, or else whenever you take capital T, okay, capital T only in place of here, in place of D2. And another formula of overtaking side distance, this is the another formula without substituting B. So as already mentioned, small b is nothing but what? VB, V in meter per second into capital T. Into capital T. So capital T is 4S square root of 4S by A. That has been put here. That's it. Or else you can use this formula. And again, yes, already I mentioned empirical formula for spacing small s is what? 0.7 VB, small VB plus 6. So this is the formulas for B and small s. So you can remember this formula in general. And again, another for capital T, you can remember this. Capital T is been given by square root of 4S by A. Okay. So while doing the problems on overtaking side distance, try to get the individual components D1, D2, D3 and do the numerical examples. So that will be helpful. Rather than taking directly OSD formula and doing it may confuse you. First determine D1 component, next determine D2 component and determine D3 component. So this is D1 component. This is D1 component. Better I will explain here. Yes. This is D1 component. VB into small t. V is in meter per second. And t you can take it as 2 seconds. And this is D2 component, 2s plus p. And this is D3 component, V into capital T. So these are some of the maximum overtaking accelerations at different speeds which has been given. If he has in a numerical example, he has not given a value. For example, here to determine t, we require acceleration, rate of acceleration value. If it has been not given, then you need to remember this because you should go to this. How much? For example, 50 kmph, the acceleration is 1.11 meter per second square. Like that, you should go through this table. There is no option. Okay, so coming to the, I will go to the numerical example, then I will move back to the, that is overtaking zone. What is overtaking zone? Because there are some criterias. I'll be sharing this. So numerical examples on overtaking side distance. So coming to the numerical example, so this is the first example. So here in the example, what he has given, just a minute. Yes, I'll try to maximize it. Okay, so I'll continue. So coming to here, the example 4.6, sorry, example 4.6, what he has given, he is talking about the speed of overtaking vehicle and overtaken vehicles are 70 kmph and 40 kmph. 70 kmph and 40 kmph. So overtaking vehicles means if I am driving a vehicle, so I am trying to overtake a vehicle, that is my vehicle, we say it as overtaking vehicle, which is 70 kmph, and overtaken vehicle means the vehicle ahead of mine is overtaken vehicle, that is 40 kmph. And respectively on a two-way traffic road, two-way traffic means from both the direction there is a traffic, if the acceleration of overtaking vehicle is 0.99 meter per second square. So A he has given directly. So he's asking us to calculate the safe overtaking side distance, OSD, mention the minimum length of overtaking zone, and draw a neat sketch of overtaking zone and show the position of signposts. So these are the whatever has to be determined. So coming to the solution, so overtaking side distance for two-way traffic. So total it will be D1 plus D2 plus D3 for two-way traffic. If for one-way traffic, you can only go for D1 plus D2. So assume the design speed as the speed of overtaking vehicle A. So V, how much he has given? 70 kmph. Already I mentioned you. This is overtaking vehicle. This is for overtaken vehicle. So this you need to convert into small v. So divide it by 3.6. As already said, divide by 3.6 for bigger to smaller. Multiply it by 3.6 for smaller to bigger. So VB 11.1 meter per second square and A already been given 0.99 meter per second square. So first determine the D1 component. Sorry, they have given in capital D. It's not capital D, it's small d. So first determine D1. So what is D1? First component VB into T. Simple. So add up T is equal to 2 seconds. As already mentioned, see, for stopping side distance, the T reaction time will be 2.5 seconds as per IRC suggestions. But for overtaking side distance, you can take 2 seconds because here the driver is only trying to find the opportunity to overtake a vehicle. That's why you can take T as 2 seconds. So 11.1 meter per second into 2 seconds will give us 22.2 meters. Please try to write the units. Don't miss the units here. Okay, so D1 component has been determined. Next we'll determine D2. So what is D2? 2s plus b. So 2s plus b. In place of b, we have written VB into T, which is a formula. VB into capital T. Okay, so first what we need to do, we need to determine small s, spacing s, using the empirical formula. Using the empirical formula, determine small s. So small s is equal to 0.7 VB plus 6. So 0.7 into 11.1, which is meter per second plus 6. So since it is an empirical formula, so whatever the last value you get, it will be in meters. No need to worry, don't get confused, it will be in meters. We are only substituting here meter per second, 11.1 meter per second. Since it is an empirical formula, the unit whatever we are getting is 13.8, which will be in meters. So spacing we got. So in similar way, we need time, capital T also, which is the time taken during overtaking operation. That's why we denote it by capital T. So that is square root of 4s by a. So we know s, that's why if you know s, then only you can determine capital T here. So capital T is equal to square root of 4s by a, and a you know 0.99 meter per second square, which has been given. So you'll get the T in 7.47 seconds. So D2 total. So at last you can write the D2 value. So what is D2 now? From this, from this equation, right? So in this equation, we determined small s, spacing s, and also we determined capital T. So 11.11 into, so here I will show it with the arrow so that there will be no confusion. D2, calculating D2. So 11.1 into 7.47 seconds, which you already got here, and 2s, 2 into s we already got 13.8 here, t we got and s we got. So d2 will be 11.05, oh sorry, 110.05 meters. So d1 we got and we got d2 also. We got d1 and we got d2. We are left with only the third component, that is d3. So d3 is for opposite vehicles. For example, while overtaking, there is an opposite vehicle coming. So that opposite vehicle will be moving with the design speed small v into the overtaking speed, that is capital T. The overtaking time, during the overtaking operation, whatever the time, that will be capital T. So because whenever vehicle A moving behind the vehicle B, right? So vehicle A will overtake the vehicle B and go to its original lane. But while overtaking, there will be an opposite vehicle also coming. That's why the opposite vehicle C, its speed, we can take it as design speed as small v, and while vehicle A is overtaking, so the time taken is capital T. That's why we'll consider capital T while considering the opposite vehicle. So D3 is equal to small v into capital T. T we already know, we got here, right? 7.47 second. So, and V we know 19.4 second. Remember here, V. So this V, we need to take this V, not VB. Don't get confused. VB and V, both are different. As already mentioned, overtaking vehicle and overtaken vehicle, right? So whenever you are determining VB, take the speed of overtaken vehicle. Here in the question he has clearly mentioned the speed of overtaking vehicle and overtaken vehicle respectively, means this implies for overtaking vehicle, this implies for overtaken vehicle. So remember small VB. If you want to determine small VB, then see what is the speed of overtaken vehicle, the vehicle ahead of you, which you are overtaking. మీ ముందున్న వెహికల్ మీరు ఓవర్టేక్ చేయాలంటే ఆ వెహికల్ ది స్పీడ్ ఏముంది, ఆ వెహికల్ స్పీడే విబి ఉంటుంది. ఓకేనా, క్లియర్? ఓవర్టేకింగ్ వెహికల్ అంటే మీరు వాట్ ఎవర్ ద వెహికల్ యు ఆర్ డ్రైవింగ్, మీరు ఇప్పుడు వెహికల్ డ్రైవ్ చేసిన వెహికల్ స్పీడ్ వచ్చేసి 70 kmph ఉంది. కానీ ఆపోజిట్ వెహికల్ అహెడ్ ఆఫ్ వెహికల్, ఆ వెహికల్ స్పీడ్ 40 kmph ఉంది. సో ఏమవుతుందంటే ఓవర్టేకింగ్ చేయక ముందు మీ వెహికల్ ఆ 40 kmph కి రెడ్యూస్ చేసుకుంటారు, సో దట్ మీరు ఓవర్టేక్ చేసుకోవాలి. సో అందుకే VB will be used for first component D1 and D2. So D1 and D2 is the component before overtaking and D2 is the component after overtaking or during the process of overtaking, and D3 is after overtaking. So that's why in D3 you need to consider the overtaking speed, that is your speed. That same speed that same speed will be will apply for the opposite vehicle coming, that is 70 kmph. So this is 70 kmph. This you need to use in D3, 70 kmph. Clear? So V into capital T. So I will get D3 as 144.9. So again D3. So D1 plus D2 plus D3 will give me the overtaking side distance. So D1 is 22.2 here and D2 is 110.5 meters. So D2 is 110.5 meter and D3 is 144.9 meters. The total will be 277.6, approximately 278 meters. So hope I'm clear, because I'm stressing more because the numerical examples are very important. Even if we are conducting the mid exam online, we will be trying to give these numerical examples with all the data required. So you need to calculate, you need to do the numerical examples, and we will be giving the options in the we will be giving the answers in the options. So you need to select the correct option. So try to practice these numerical examples at your home once again. So if needed, I will be sharing this OneNote. Just a minute. Yes. So I will be sharing this OneNote with you in the group itself. You can just go through this OneNote, which includes all the side distance notes, that is the analysis of stopping side distance, analysis of overtaking side distance, and so on. Yes. So moving back to the second example. So before that, there are two more determination in this example. So he's asking us to determine the minimum length of overtaking zone. So here what happens? Here I explained you the overtaking zone. See, overtaking zone is provided whenever there is no possibility of providing an overtaking side distance along the road. So they go for an overtaking, providing an overtaking zone. So here you can see 3.75 meter is the single lane, right? So 7 meter will be the lane at the overtaking zone. So they will try to give some extra width on the either side of the road for overtaking purpose. So that overtaking zone, we usually say it as 3 times of OSD to 5 times of OSD. So minimum length is 3 times, desirable length is 5 times. So we need to calculate 3 times of OSD first and later on 5 times of OSD both. So that will be 3 times of OSD. So we know the OSD value 278 meters. 3 times of OSD will be 834 meters. 5 times of OSD will be 1390 meters. So we can say this as this overtaking zone. Overtaking zone is like here I can write. So this overtaking zone, yes. So this overtaking zone is from 834 meters to 1390 meters. In that way, you can write. So this diagram you can draw. So you can write on. So this is signpost 1. SP1 means signpost 1 here. So you can draw this neat sketch SP1. So that's why I have drawn this sketch and I have put here as a screenshot here. So and later on OSD value you can write here. It is this image is not clear. That's why I written here. You can see that is 278 meter. And later on again 278 meter here again signpost 2. So signpost 1 is nothing but overtaking zone starts. Signpost right, signpost 1 and signpost 2 is nothing but overtaking zone ends in that way. So again OSD value you can write here, and this is SP1 when you are on the another side of the road. SP1 and again SP. So this is SP2. Signpost 1, signpost 2. So this so at third he has asked us to write the details of the overtaking zone with the help of a neat sketch. So like you can draw this. So here it has written again SP1 here, SP2 here, and this is 834 to 1390, and this is 278 OSD, and again 278 meter OSD, and here again 278 meter OSD, and here 278 meter OSD in that way. Okay, so this numerical example in the exam he may ask you for 10 marks. Okay. So coming to the next example 4.7. So in the example 4.7, what he has asked to calculate the safe overtaking side distance for a design speed of 96 kmph. Assume that all other data suitably. Simple. He has not given acceleration value, and also he has not mentioned is it a one-way traffic or is it a two-way traffic. So nowhere he has mentioned anything. So what we need to do, we need to calculate OSD, overtaking side distance for one-way traffic, and as well as overtaking side distance for two-way traffic. So this type of problems they may ask, but very less, because all the data has to be given and it should be very clearly. If he is asking for more marks, for example for 15 marks, so he may ask this type of questions. Okay, so coming back to, so OSD, D1 plus D2 for one-way traffic, D1 plus D2 plus D3 for two-way traffic. So speed he has given V is equal to 96 kmph. So here he has not mentioned like is it for a overtaking vehicle or overtaken vehicle. As already mentioned to you, so overtaking vehicle means if you are traveling in a vehicle and a vehicle ahead of you, if you want to overtake, so your vehicle speed will be the design speed V, and the vehicle ahead of you, we call it as overtaken vehicle. Its speed we denote it by VB. So since he has not given VB, so there is a formula to determine VB. Capital VB is equal to V minus 16 in case of capital V. But in case of small VB, that is small v in meter per second, VB is equal to small v minus 4.5 if V is given in meter per second. So since here V has been given in kilometer per hour, so capital VB is equal to capital V minus 16, that is 80 kmph is capital VB. So again, determine, if you want, you can determine small VB and do with the help of small VB. Here I have put this example because this is using capital VB. So here what he has taken D1 in terms of capital V, that is kilometer per hour. VB also in kilometer per hour and capital V also in kilometer per hour. So 0.278 capital VB into T, that will be the formula. You know that small small v into T conversion to capital V into T, which are already studied in stopping side distance. So 0.278 capital VB into T, which gives us 44.8, the first component D1. Next D2, again 0.278 VB into capital T plus 2S. So the formula, if in terms of small v, what it will be? 2S, right? 2S plus, that is small VB into capital T. So in place of this small VB, I am taking 0.278 V into 0.278 into capital VB. Okay, so again same, determine S value using VB, capital VB. And again, whenever the capital VB you take, the formula of empirical formula again changes, that is 0.2 capital VB plus 6. See the first example there, V was in meter per second. In this example, V is in kilometer per hour. That is the difference. To understand the difference, I am explaining you this also. It is left to you. If you want, you can convert this 96 into the meter per second. If you want, I will tell you the value also. So 96 divided by 3.6, that is 26.67 is the value. 26.67 is the value here. So 26.67 meter per second. Meter per second is the value. Okay. So coming to this VB, it is 80 divided by 3.6, that is 22.2 meter per second. 22.2 meter per second is the value for small VB, 22.2 meter per second. So you can use this small VB and you can determine the D1, D2, D3 as per previous example. So coming to D2, so 0.2 into capital VB plus 6 whenever V is been given in kilometer per hour. So S is 22 and again capital T. So what happened? A he has not given. So A it is 2.5 kilometer hour per second. So that I have already shown you here. Here you can see. So this table where rate of acceleration is been given in kilometer hour per second. That is, what is the speed given there? 80, right? So 80 kmph. That is 2.56. 2.5 years taken. 80 kmph. 2.5 years taken. 2.5. Right? So 2.56 years taken. So 14.4. So again, this formula will also change. That's why you can better go with the this formulas only, because this formula, if you are remembering both the formulas, you will get confused. So this, I just want to show you, because some will be having their own doubts, like, sir, I will take capital V only directly. But when you take capital V only in overtaking side distance to determine the components D1, D2, D3, the formula will changes. S formula changes, T formula changes. T formula will changes to 14.4 S divided by A. But for whenever V is been given in meter per second, the formula is 4S by A, small a. But whenever capital V in meter per second, capital V in kilometer per hour, you take 14.4 S divided by capital A. That becomes the formula for capital T. So we'll get D2 and later on D2 from this, right? By substituting capital T and S, we'll get D2 value. D3 again, small v into T. In place of small v, I'm taking 0.278 capital V. So that I'll get D3. So I can tell you that you can do this example using V in meter per second and get me the values. So I will be asking this in the afternoon. So please note on this question. So give me the values of S and capital T in the afternoon. I will be having class again at 2:50, and again at 11 o'clock, if possible, I will only be taking the class at 11 again. So afternoon, I need this question solution using the previous question details like small s, capital T. So D1, D2, D3. So we get all these three. So all put together. So D1 plus D2 plus D3 will give me the overtaking side distance, right? For two-way traffic. Only for one-way traffic, only 2 is enough. D1 plus D2 is enough. D1 plus D2 is enough for one-way traffic. So that's it. And coming to the another example, yes, this is a small example I will discuss and then I will wind up. Okay, so coming to the numerical example on SSD and ISD. See, ISD is nothing but intermediate side distance. So usually in some cases there may not be possible of providing overtaking side distance and overtaking zone also. So there they will go for providing an intermediate side distance. So intermediate side distance is nothing but 2 times of stopping side distance. So here in the numerical example, he has given the design speed of a road is 65 kmph. The friction factor is F is equal to 0.36. The reaction time of the driver is 2.5 seconds. Calculate the headlight side distance, nothing but stopping side distance I can say, and intermediate side distance required for the road. So stopping side distance, the formula is, so this is the formula. So in terms of V in kmph. So 0.278 capital V into T plus V squared divided by 254 F. So capital V directly you can substitute, and T has given 2.5 seconds, or you can assume it if he has not given. 254 into 0.36 is the coefficient of friction he has already given. So stopping side distance is 91.4 meter and headlight distance remains the same. Whatever the stopping side distance will be there. So intermediate side distance will be 2 times of stopping side distance, which is 2 into 91.4, which is 182.8, or approximately you can write it as 183 meter, which will be the intermediate side distance. So this is just to know the safe OSD. So safe overtaking side distance mainly depends upon the number of lanes. So as already mentioned, 2 lanes with a two-way traffic. What you can do? 2 lanes with a two-way traffic, you need to take safe OSD as D1 plus D2 plus D3. 2 lanes with one-way traffic, you can take D1 plus D2, means there will be no opposite vehicle coming. If 4-lane two-way traffic, in case of 4 lanes, there again the formula remains the same. That is because we will take 2 lanes and we will design the stopping side distance. And direction of traffic is also main for the safe OSD. Direction of traffic means two-way traffic, one-way traffic. Overtaking zone as already mentioned. So SP1, signpost 1, signpost 2, OSD. So this is the overtaking zone provided wherever there is no possibility of providing overtaking side distance. So minimum length of overtaking zone 3 times of OSD, desirable length of overtaking zone 5 times of OSD. In general, OSD must be on the straight road. That is important. So single lane SSD is sufficient, right? That is for one way. For two-way, intermediate side distance is required. So any other multi-lane overtaking side distance is always required. So that's it. So if you have any doubts, you can ask. So I'll try to. I've taken the attendance already in between. Yes. So another 2 more minutes. You can ask if you have any doubts. Because since it is a numerical example, I should give some time to students also. Yes, madam.
Sir, good morning, sir. I have a small doubt. Ikkade, sir. Assume VB is equal to V minus 16 అనేది ఎందుకు తీసుకున్నాం, sir? We can take 18, 17 అలా ఎందుకు తీసుకున్నాం?
అది ఎంపెరికల్ ఫార్ములా వాళ్ళు ఇచ్చింది డైరెక్ట్ ఐఆర్సీ ఇచ్చింది ఎంపెరికల్ ఫార్ములా. సో ఇప్పుడు ఏమవుతుంది అంటే ఇప్పుడు దట్ ఈస్ స్మాల్ వీబీ ఉంటుంది కదా, ఇప్పుడు స్మాల్ వీబీ అంటే ద రెడ్యూస్డ్ స్పీడ్ ఆఫ్ ఓవర్టేకింగ్ వెహికల్, రైట్? సో దే హ్యావ్ డన్ ద అనాలిసిస్ ఆఫ్ different speeds of vehicles running at different speeds. For example, they have taken several samples and they have done analysis and they have given this formula, that is -16. అంటే ఇప్పుడు నువ్వు ఫర్ ఎగ్జాంపుల్ నువ్వు ఒక 60 kmph లో వెళ్తున్నావు, ముందు ఏదో వెహికల్ చూసుకున్నావు అనుకో, ఆ వెహికల్ నువ్వు వెళ్తున్న స్పీడ్ 60 kmph, నువ్వు ఒక 50 kmph బిలో రెడ్యూస్ అవుతావు, లేదంటే 45 kmph 40 kmph లో వెళ్తావు దాని వెనక. వాళ్ళు అలాగా డిజైన్ చేసి ఇచ్చారు. సో దిస్ ఈస్ VB is nothing but the reduced speed of overtaking vehicle trying to overtake. అందుకే ఇచ్చారు -16. ఓకేనా? ఈజ్ యువర్ డౌట్ క్లియర్?
సార్ అది వాళ్ళు డైరెక్ట్ గా ఇచ్చారా సార్?
డైరెక్ట్ గా ఇచ్చారమ్మా. క్యాపిటల్ V -16 ఇన్ కేస్ ఆఫ్ V in kmph, స్మాల్ v -4.5 ఇన్ కేస్ ఆఫ్ V in meter per second. Okay. So VB, in most of the cases, he may not give you the VB value, so you can determine using this formula.
Sir?
Ama. ఈ ఎగ్జాంపుల్ చూడండి, ఈ ఎగ్జాంపుల్ డైరెక్ట్ VB ఇచ్చేసారు, దట్ ఈస్ 40 kmph. చెప్పమ్మా. హలో ఆమా చెప్పమ్మా సుమేరా.
సార్ ఏ వాల్యూస్ అనేవి కొన్ని టేబుల్ చూసుకుంటూ మనం తీసుకుంటున్నాం కదా సార్, 2.5 8 కిలో ఆంపియర్స్ కింద అని తీసుకుంటున్నాం కదా సార్, అవన్నీ టేబుల్ వాల్యూస్ అని గుర్తుపెట్టుకోవాలా సార్?
గుర్తుపెట్టుకోవాలి, ఆల్మోస్ట్ అన్ని ఇస్తారు వాళ్ళు, ఎక్కడో రేర్ కేసెస్ దే మే నాట్ గివ్. ఇది ఒకటి గుర్తుపెట్టుకోవాలి మీరు, యాక్సిలరేషన్ వాల్యూస్, తర్వాత స్టాపింగ్ సైడ్ డిస్టెన్స్ లో వచ్చేసి అక్కడ మీరు ఫ్రిక్షన్ వాల్యూ గుర్తుపెట్టుకోవాలి. యూర్ ఆన్ టేబుల్ అమ్మా ఫ్రిక్షన్ వాల్యూస్.